Well, good afternoon, everyone. My name's Carl Larsen from RMCG, and welcome to webinar number 3 in our winter webinar series on salinity and potato production. Today, we're tackling managing hydrophobic soils in potatoes, and this follows our last 2 sessions. The first on monitoring for improved management, and the second, know your salts to better manage potato nutrition. So we're joined again today by project lead Julie Finnigan from Survag down in Tasmania, and we've also got Bruce Scott from EE Muir and Son and Campbell's Fertiliser on the line, our trusted panel. And we're going to walk through in the next half an hour the key resources and some of the findings from the multi-year project. Just before I do hand over to Julie though, I'll just walk through a couple of things on the go-to webinar control panel for you. If you haven't joined one of these sessions or you're returning back and have forgotten, like me sometimes, we've got our questions pane in the panel there. Importantly, that you can type a question at any time. That comes through to me and I'll make sure we put it to our panel and get that answered for you. The second thing I just wanted to highlight was the handouts panel as well. We've got the third fact sheet in the series of 4. You're getting first access to that today by participating, and also a couple of other resources that Julie will refer to throughout the session are all there to download and take away straight from the session, so you're not hunting around the website. But without further ado, Julie, I might hand over to you to kick us off. Thanks very much.
Wonderful, thank you, Carl, and welcome everyone to our 3rd webinar. So as Carl said, this is the 3rd in a series, and it's following on from a Hort Innovation project that was focusing on the impact of groundwater quality on centre pivot grown potatoes. So over the past 2 webinars, we've outlined some of the issues with our irrigation water, which is primarily groundwater sourced in South Australia, and the levels of salts, in particular the sodium chloride that we're applying with those. So first up, before we go too far, though, I'd really like to say a big thank you to our funding bodies. So with Hort Innovation, the fresh and the processing potato levies, obviously the Australian government, we've got a lot of people that have been involved on the sidelines through RMCG, Soil Wealth, AusVeg South Australia, in particular EE Muir and Sons, and a lot of the people that have done some hard yards on the ground, people that have contributed to fact sheets, etc. In particular, a big thank you to all of those who had opened up their farms and properties and enabled us to do some work on their ground. So a big thank you to everyone there. So just in a little bit of a wrap up in terms of where we're looking at South Australian potato production. South Australia is the largest producer of potatoes in Australia. So it's around about 385,000 tonnes of potatoes that are produced annually, and about 80% of those are for the fresh market. So when we're looking at managing potatoes and managing our soils, it's really, really important that we start looking into this, and in particular with our groundwater quality, taking a bit of a focus on that. So we know salinity affects a lot of our agricultural land across Australia, and a huge amount of money has been invested over the years. And similarly, salinity affects potato production in South Australia, but also anyone who's listening from elsewhere will be able to pull information from this presentation towards their management as well. So the irrigation waters typically ranged in salinity levels, but they're all very high in sodium and chloride. And one of the things that we did notice is that when we were monitoring from the start to the middle and to the end of the season, quite often that the salinity levels, the salt and the chloride would increase from the start to the end of the season. And therefore, when we're cropping and irrigating, we're also seeing an increase in sodium chloride levels within the soils that we're cropping. So the long-term effect on the soils is very important, as well as how it impacts on the health and quality of our potatoes and tubers that it produces. So some of the things that we found when we were working in South Australia is that soil types are quite variable. And in some places we would have quite very deep sandy soils, typically on the higher ridges, and then on the lower slopes we could have sandy soil, anywhere between 5 and sort of 15 centimetres over quite a heavier subsoil. And what we're finding in those situations is that the heavier soils tend to leach less, hydraulic conductivity is less, they accumulate more salts. The lighter soils will flush those salts away a little bit more easily. But there are a lot of other challenges that we found growers were being faced with while they're producing their potatoes. So heat stress is one in particular, and I think as we move through the years and we find that conditions are warming up, this is always going to be the case. But wind erosion, some of the soils are very difficult to wet up, and increased water use. I mean, they're all factors that impact on growers and the costs to producing potatoes. So some of the things that we found from our very first year that was limiting potato production and growers were finding difficult to manage was these hydrophobic soils. So a hydrophobic soil is a soil that repels water. It's very difficult to wet up at the start, and it's because of a lot of the waxy residues that are present within the sand. So this is one of the reasons why we tried to focus on this in future years to facilitate improved water infiltration and water availability to our potato crops.
So Julie, just before you move to your next slide there, we might just launch a quick poll for everyone on the line to participate in. We're just asking the quick question there, are you dealing with hydrophobic soils in your region? We're really interested to know your response, either yes or no. If you can click one of those options and submit, I'll be able to share back the results with everybody, just to get an idea of who's battling with this on the line, and we can get a bit better idea. So I've had about half the people vote. Keep those coming in, and I'll share them back shortly. Excellent. So I might just close that and share back the results with everyone. So Julie, what we're looking at, we've got just under 60% saying yes, they are dealing with hydrophobic soils or they're a problem in their region, and about 45% saying no. So a bit of an even split there.
It is an even split, and it's one of those things that, you know, I found communicating with a lot of growers in South Australia that the hydrophobic soils were an issue. We do have hydrophobic soils in places here in Tassie as well, and no doubt in other regions. Bruce, have you had much exposure to hydrophobic soils in Victoria?
Yeah, Julie, I think most of the sandy soils, like when you go up into the northern soils up on the river, East Gippsland, some of those areas, most of our good vegetable growing soils are, you know, often in that zone where they're very sandy, have the same sort of issue. So yeah, it's a widespread problem, not just South Australian and potatoes. It's something that, you know, we're dealing with in all of our veggie production.
Yeah, so it's, you know, given that it is fairly widespread and we are trying to be far more efficient with the water that we're applying for a whole number of reasons, we really need to try and make sure we can get the water down to the roots where we need it. So some of the implications of hydrophobic soils obviously is poor water infiltration, and quite often we find that we can apply the water and it will just run off. And a lot of the growers that I'd spoken to said they were finding it very challenging to actually wet the soils up ahead of planting. Therefore, you know, you're looking at costs of the water itself, the cost of diesel or whatever to actually pump the water on, and then you're also got the additional costs of the salts that we're applying with that water. So if we can be more efficient in getting the water on and into those soil profiles right at the start, that's very important. So once we do water these soils up, what we're also finding is that there were very dry pockets that were occurring within the potato mounds. So we might get water infiltrating in certain areas, but because of those waxy residues, it's not an even penetration. Because of that, we often get uneven growth of our potatoes. So Bruce, what's the impact of access to nutrients when we have these hydrophobic soils?
Well, it's pretty severe, Jules, obviously, because they're not actually getting the moisture with the fertiliser to activate it. And it's one of those funny things because salinity itself, we often say, looking at the paddock, you expect to see an uneven result because the salt is quite variable across the paddock. But here's another implication from the hydrophobic soils. It's also producing that same sort of uneven pattern because of the water, the nutrition. It's just a problem that can't readily be solved unless you've got a way to make that water penetrate through the whole profile across the board.
So following through from that as well, I suppose it's not just our nutrients, but it's also some of the other chemicals that we apply, the likes of some of our herbicides, etc., would probably not penetrate to the areas that we want them to if we can't wet that soil up and provide that movement for it within the soil profile. So one of the other things that we found was really quite interesting too was the ability for these hydrophobic sands to blow and to move and for the mounds to degrade in the weather conditions in South Australia. So part of that, I suppose, is that we're getting the slumping of the mounds, and as the tubers are developing, quite often we get the greening as well as they're exposed to air. So in summary, some of the tuber defects that we can often find because of uneven water penetration through the soil profile might be the likes of cracking. So cracking can also be an excess supply of nitrogen at times, but also that uneven watering can create the cracking as well. We can get misshapen potatoes, and this again can occur in a number of different ways depending on the timing of the growth and that wetting and the drying period for the potatoes. So something else here, and hopefully you can see it okay, is we often get these raised lentils. So they're looking like little white dots here, and quite often this occurs when they lay in wetter soils where we can't remove the water enough. But some of the downside from this is that when it does dry again, these can dry out, and they can be point sources for infection to occur later on. So again, this uneven watering can create ongoing issues with our tubers in that regard. And here we've got, the aspects of greening. If our potatoes are exposed, they will turn green, and while it might not necessarily be a big issue for processing potatoes, that could play a big part on the yield at the end of the day for fresh market potatoes. So when we start looking at the hydrophobic soils and various management options, I suppose one of the first things I would like to look at is the longer term options, something that we can apply that will have ongoing benefits. And cover cropping and green manures is a fantastic way to get organic matter into the soil profile and help to alleviate some of that hydrophobicity. However, cover cropping, green manures, I know isn't always an option. It's the cost of the water, the availability of the water, and the time frame, because some of these, while some crops, we have a 4 or 5 year rotation, some are cropped more continuously. So it's the ability to have the time, the water, etc., to actually manage that crop ongoing. Something else that we can do slightly longer term, but it would obviously need ongoing inputs, is the likes of additions of compost. So compost can be really beneficial, and we are going to talk about that in our webinar on Thursday afternoon when we have Dr. Doris, our soil doctor, back again. So these are features that help improve the condition of our soil over the longer term. So if we can implement them, they are fantastic. If we can't, we obviously need to start looking at shorter term options. So some of the shorter term options, and I suppose some people might question whether claying is shorter term or longer term, but the likes of claying or clay delving, where we can actually add clay or bring clay up from greater depths, helps to increase that clay level and water holding capacity within the soils. But some of the things to think about is, well, what are the costs involved? Do we actually get a really good spread and distribution of the clay within the sandy soils? Will it improve the actual infiltration of the water of our sandy or hydrophobic soils at the start? It certainly may help to increase our water holding capacity once the water does get in there. So that and the costs involved, they're things that I suppose need to be considered, but it's certainly a practice that does occur. One of the other things that we can look at, and a lot of people use them, you hear it a lot in potted plants, more domestic use in particular, is the likes of the gels and the crystals. So when we apply the gels and the crystals to the soil, they do swell up and they do hold a lot of water, so they can provide ongoing water to the crop until that does dry out. But if it does dry out, they often will not re-wet as easily. And I suppose it can provide or increase the time frame between irrigations for our crop, given that it's holding that additional water for us. But longer term, it's not going to help with the initial infiltration of water into our soil profile. And I still think the ability to have uneven watering is likely to occur. So I have been, whilst I haven't had any direct experience with it, it's a very reputable soil scientist has said to me once that, they're not that good either, in that they can clog soil pores. So by clogging the soil pores, you then remove the air spaces, etc., and the ability of nutrients and moisture to flow through as well. So potential issues there, but certainly options to help hold moisture within the soil profile.
And Julie, just as you've been going through those shorter term management options, we've had a couple of questions come through, so thanks everyone for sending them in. Merrick was first with just asking, have you looked at planting in sands without mounding?
I haven't, no. So I don't know if many people have. It would prevent the erosion of the mounds over time, so that's a very good question. I can't answer anything beyond that, I'm sorry.
That's fine. Thanks for that, Merrick, and thanks, Julie. We also had one from Neil saying, what about the use of hydrophilic or hygroscopic and humectant-based organic polymers? Have you had much experience or a look at those, Julie?
No, I haven't. No, I haven't. So, yeah, look, there's probably a wealth of information there that I haven't read. You would imagine it would help in that natural soil ability, but I'm sorry, I don't have any experience to be able to offer much in that regard there.
Yeah, no, that's fine. And look, the last of the three before we do move on, Julie, and hopefully this one is a bit more straightforward. Just Will's asked around the environmental challenges with some of those gels and crystals.
Yeah, so I suppose in terms of, if we start looking at the longer term environmental challenges, breakdown of the product, I'm not really sure. Don't know if Bruce, you'd be able to have any input to that as well, but we are looking at adding an inorganic substance.
Jules, I think there is an issue about, what you're putting into the soil and knowing what its long-term effects are. So a lot of people are very wary about those sort of products, whereas in a nursery situation in potted plants, they're quite widely used, but in the field experience, maybe there is more use of products like humic acids and, that question before about the humectants and that sort of thing. Some of those products have probably got some advantages without the disadvantages. So, yeah, it's a wise thing to be very careful about what you're choosing to put into the ground, because if you can't get rid of it and some sort of toxin later on, you're in a lot of trouble. So
yeah, very true. And look, I did speak to one client, and he had tried one of the gels, and he said he found it really difficult to work with. Wouldn't go down that path again. So when we were looking at implementing trials, there was certainly a lot of questions asked there. So if we look at soil wetting agents, conditioners and products to improve the health of our soil, there's a load of money, a load of research being done towards this. So this is one example here. It was a paper that I found on the internet. So it was only earlier this year, but it was talking about over $120 million US that's invested into these sort of products for soil wetting agents. So this is a large market. Similarly, I've seen very similar numbers with the likes of biostimulants and biologicals. So I think this whole area of helping to improve our soils to function more naturally is growing at a rapid rate. And whilst we're still learning a lot at the moment, I think we're going to be seeing a lot more available and perhaps a lot more products that are going to be far more environmentally friendly to use in the future. So when we do look at soil wetting agents and conditioners, part of the reason that they work is that they do strip those waxy residues from the sand particles, which then helps the soil moisture to actually penetrate through into the soil profile, lowering that surface tension. So an amazing array of product choice, and we certainly chose to look at a product where we were looking at a lot of R&D and safety behind it. So any product that does come to the market, you know, there is an extensive amount of R&D. They are looking at safety. They're looking at the environmental impacts, the handling for people as well. There's the ongoing issue in terms of consumer safety as well. The effect on soil microbial populations is very, very important, because we're learning more and more how beneficial the microbial populations are to the accessing of nutrients, etc., within our soil profile and our crop health. And obviously, you know, the efficacy, how well do these products work? And a lot of the time, you know, we need to trial these things for ourselves to really get a good understanding of how they work. And then there's the regulatory approval that these products need to achieve as well, and it's quite a rigorous process. So, you know, rest assured that when you are looking at products, make sure they are backed by really good R&D. So one of the trials that we had a look at in South Australia was using a product that was made from the natural cold-pressed orange oil, and it's got a special blend of surfactants in it as well. So it's almost an organic product, but not quite. And part of the reason that we used it was because of the natural composition of it. Very safe on biology. It's been backed through research there. The product could be applied either in furrow or through fertigation, for instance, as a blanket application, and it could also be applied with the typical chemicals and fungicides, etc., that are applied using or for potato production. So it had a lot of really good benefits, but in particular, another one that I thought would be fantastic for potatoes is that the product had been shown to have improved benefits for the soil for periods of up to 8 months. So we should see that ability of improving that soil wetting and that uniformity within the soil profile throughout the life of that potato crop. So when we did first apply it on our very first trial, we had the blanket application applied over a quarter of the pivot. And it was really quite interesting in that our growers said it was just amazing. It was applied on, say, a Thursday afternoon. That weekend, it was incredibly windy, and he said he was out in the pivot and, you know, the rest of the paddock was blowing away, and he said that quarter of the pivot just stood where it was. It didn't move. So that was a really good indication that, you know, we're getting the water into the profile, and it was helping to hold the sands in place. When the irrigator walked over the pivot, the water very quickly bubbled and disappeared where the product had been applied compared to the control areas. And yeah, the grower comment was that it was really pleasant on the nose and very, you know, handling was very easy. So in terms of grower handling, very, very easy to utilise. So, and I'm not sure if you can see this very well or not, but I did do some screenshots from a South African Facebook post, and this is showing where the water was dropped on here, where it was mixed with the transformer. Sorry, I can't see this very well. And but where sorry, here is where it was dropped on with the transformer and it just sort of disappeared, yet where the transformer wasn't, it just sort of bubbled on the surface. And again, you can see here the difference in the product where we get that deep penetration versus it sort of just sitting at that surface. So it's amazing to see it in use. And I know we're pushing for time here, but looking at some of the trial results, what we were finding is very uniform wetting of our potato mounds. When we were digging through them, there was almost a clear elimination of a lot of the sandy pockets that we were finding in the areas where the product wasn't applied. We had significant reductions in tumour blemishes, and in particular a 30% decrease in that greening. And I think a lot of that is attributable to the mounds sort of blowing away. So what we also found was the grower was getting a lot of noticeable differences in yield as he was harvesting. So this graph does actually show where we had different types of application. So we could look at in furrow at about 2 litres per hectare, and for this particular trial we applied it as a broad scale application or a blanket through the pivot at 10 litres per hectare. So this was a combined product look at and the control, and what we were getting is a very marked decrease in the amount of blemishes compared to where we did apply the product. So some very good increases in marketable yield from using this product. Similarly, this is from a trial in processing potatoes here in Tassie that was harvested earlier this year, and again what we're seeing here is an increase in over 7 tonne per hectare for where the product was applied compared to the control areas. So there's a more uniform penetration, more uniform watering, less defects in terms of potato shapes, misshaping potatoes, less raised lentils, less green potatoes, and it just overall uniform growth of the potatoes through that more or greater ability to access nutrients and moisture throughout the growing period. So in summary, you know, what we're finding is that the hydrophobic sands were impacting quite a lot on the production of potatoes, be it for fresh market or processing potatoes. In particular, that increased water use, increased salt loads being applied along with that, poor infiltration and watering, and we're seeing that in the misshapen potatoes, the mound degradation and the greening that we're seeing, and overall a decreased quality and yield. But through the use of this soil conditioner, we were seeing improved infiltration right from the word go, uniform wetting of those potato mounds, and it also improves that re-wetting should the soils dry out in these hot, windy conditions. So great significant reduction in tumour blemishes, less erosion of mounds, less greening. So look, this is I suppose a good example. If people have got more questions with regard to the hydrophobic sands and some of the management, there is the fact sheet with some more information there. So yeah, it's pretty much it, and hopefully we've not gone too much over time as well.
That's fantastic. Thanks, Julie. Right on time. So thank you very much for that. We might throw it open to you now. We've had a couple of other questions come through. With our limited time remaining, we'll try and get to as many of those as possible. We've got a follow-up question from Marek first, just asking, have you come across any irrigation strategies that help infiltration, such as lower application rates or irrigating after rain?
Oh, look, certainly I think if you did irrigate after rain, you might see some benefits depending on the situation, the amount of rainfall. But I suppose we need to be very careful when we're irrigating to make sure that we maintain that moisture in the profile and we don't get that drying and the pushing up of salt. So yeah, I can't answer much beyond that, in that I think for each scenario we need to monitor. There's a lot of technology out there to assist with that, but to really keep an eye on how we apply that water. So obviously if we had variable rate irrigation, that would assist in that application of water across these variable pivots, but it's not always accessible or easy to implement in some of the regions where our water is incredibly hard as well. So there can be issues. We can improve how we apply our water, and it's a matter of, I suppose, a consistent juggle with what rainfall we do get, not overwatering, not underwatering, and in particular on these variable soils.
Yeah, absolutely. And Bruce, any final thoughts on that from your end?
Oh, look, the only one, Carl, is that with the hydrophobic soils and using something like that orange oil product, it's quite synergistic with the calcium products. We're often using the calcium products like calcium nitrate, calcium thiosulfate to help with the salinity angle. So if we've got the salinity under some sort of amelioration with that, and we've got a better way of getting the water where we want it, the two things work hand in hand beautifully.
Absolutely. Yep, absolutely.
Great point. Excellent. Well, look, we've just run slightly over time. I'm conscious people have things to get to in their day. So a quick recap, our first 3 sessions there, we've gone through monitoring, nutrition, and then managing hydrophobic soils today. If you haven't already, please do sign up for our 4th and final webinar this Thursday on organic soil amendments, biologicals and biostimulants. So we'll have the full panel back, including Doris Blasing for that session Thursday afternoon. If you want to register, soilwealth.com.au/events, it will be right at the top of the page. And we'll make sure a recording of this session and all the previous ones are uploaded to the Soil Wealth ICP website as well. But Julie, Bruce, thanks again for your insights. Fantastic and really great as always. Thank you too for everyone's participation today, and we'll see you later in the week. Thanks, everybody.
Thank you.